Okay, section 2.13, roots and multiplicities. We're continuing our topics about graphing polynomials. We'll look at it, I've got a calculator with a URL here, but we're looking at a polynomial based on x minus 1. So if I look at x minus 1 by itself, just x minus 1, that's a line. You see that line graph there below? Let's take a look at it on a graph. So what you see is x minus 1, and you see it has an x-intercept at 1, 0, y-intercept at 0, negative 1. What would happen if that were x minus 1 squared? You should recognize this as the graph of a parabola. It has a x-intercept at 1, 0, y-intercept of 0, 1. Okay, if I go back and look, so I see here x minus 1 squared. That's what you see here in the second graph. What would happen if I had x minus 1 cubed? So if I go along with my graph, if I cubed it, I see the value. So look at the difference between x minus 1 squared. What happens at the point 1, 0 along that x-axis? Okay, it looks like here the graph goes down to the point and it bounces back up. It does not cross the axis. And x minus 1 cubed, it does cross the axis. And if I raise it to the 4th power, it does not cross the axis. Raise it to the 5th power, it does. So you'll see this alternating behavior. X minus 1 to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th, to the 6th. So every time I alternate back and forth, I see it crosses the axis, does not cross the axis. So I can generalize here and say when I have an even degree, so this is x minus 1 to the 8, I do not cross the axis, okay? So if you go back, that's what you see here for the cases we just showed, were for raising x minus 1 to the 1st, to the 2nd, to the 3rd, and to the 4th, okay? And what you see in each time, when the exponent is odd, I cross the axis as that root or 0. That's my x-intercept. When the exponent is even, I do not cross the axis. So that's the basis of what we're going to be doing graphically in this section. So if I look at this particular case, we started out with x minus 1. Okay, it had a root at x equal 1. X minus 1 squared had a same root, but we'll say it was a root of multiplicity 2. X minus 1 cubed, that was a root of multiplicity 3. X minus 1, same root, multiplicity 4. So in this case, when the multiplicity is even, I do not cross the x-axis, okay? So in that case, I do not cross. When the multiplicity is odd, I will cross the x-axis at that point. So that's what we're looking for when we look at our polynomials, or looking for the multiplicity of the roots tells us the behavior along the x-axis. Okay, so let's look at a few examples. Let's look at this. What is the degree of this polynomial? Well, that first term gives me an x squared. Here I get an x cubed, and here I get an x. So this is a 6th degree polynomial. That's an even degree. The leading coefficient. The first term will give me a 1 squared, and then I get a 1 cubed and a 1. I multiply all those together. My leading coefficient is 1. That is a positive number. Okay, so I know immediately, even degree, positive coefficient, this graph will go up on both ends. That is my end behavior of this graph. And that tells me how to answer these questions down here about the end behavior. So it goes up on both ends. As x goes to negative infinity, that means I travel to the left on the x-axis, my y values go up. As x goes to the right, my y values also go up. Now let's look and see, what are the roots? Well, x minus 1 is a factor, so that means 1, 0 is a root, negative 2, 0 is a root, and negative 4, 0. Those are the 3 roots, or x-intercepts, or solutions. And I have a multiplicity of 2 at x equal 1. I have a multiplicity of 3 at x equal negative 2. What is my y-intercept? The y-intercept is found by setting x equal to 0. So when you set x equal to 0, you get negative 1 squared times 2 cubed times 4. That is 8 times 4, that's 32. So the point 0, 32 is the y-intercept. And now I know enough to graph this guy. So 0, 32, that is my y-intercept, okay? My x-intercepts are going to happen along the x-axis at 1, 0, negative 2, 0, and negative 4, 0. Now, the multiplicity will inform what happens. So the multiplicity of 2 at x equal 1. So that's an even multiplicity. I will not cross the graph at x equal 1. There's a multiplicity of 3. That's an odd number at negative 2. I will cross the axis here. And there is no multiplicity raised to the first power of x equal minus 4. So I know that I cross the graph at negative 4 and negative 2, but not negative 1. So the only thing this graph can do is it starts up here, it crosses, goes through the y-intercept. It cannot cross there, and it has to go here. So this gives me my graph. It may not be as accurate in terms of the highs and the lows, but it does have one thing correct, or several things. The end behavior is correct. The x-intercepts are correct. The y-intercept is correct. And the right behavior along the x-axis, crossing versus not crossing the axis, is all there. And that's what we really wanted to see for that. Let's look at the next one. What is the degree of this polynomial? This is a 5th degree polynomial. The first term is going to give me an x. The next term gives me an x squared. The next one an x squared. That's a 5th degree. That is an odd coefficient. Excuse me, an odd degree. What is the leading coefficient? I see a negative sign. I see a 1 in front of the x. I see a 1 in front of the x squared. And I see a 1 in front of that x squared. All of that multiplies to be negative 1, negative leading coefficient. So an odd degree polynomial with a negative coefficient. So odd degree with a negative coefficient is going to go up over here and down over here. So that tells me the end behavior. When my x values go to the left, my graph goes up. When my x values go to the right, my graph goes down. Now, what are the zeros, the roots, the solutions, the x-intercepts? Those are 1, 0. Now, look at x squared plus 2. Set that equal to 0, and you get x squared equal negative 2. X is equal to plus or minus square root of negative 2. X equal plus or minus square root of 2i. That is a complex number, okay? So that root is complex, not real. So we do not graph that on a real plane. So I will not be able to graph that as a real root. That's complex. If I look at the last term, negative 1, 0, has to also be a root. Multiplicity. There is a multiplicity of 2 at x equal negative 1. Okay? So now let's figure out the y-intercept. The y-intercept is what you get when x is 0. So you'll get negative. You'll have a negative 1 times 2 times 1 squared. That turns out to be 2, or 0, 2. So let's plot what we know. So this is the point 0, 2. And then I'm going to need 1 and negative 1 along my axis. This multiplicity of 2 at x equal negative 1 means you do not cross the axis there. I will cross the axis at this point and at the y-intercept. So the only thing that this graph can do, it has to bounce, go through the y-intercept, and go this way. So I've got the end behavior, I've got the y-intercept, I've got the x-intercept. Okay, that is all correct. Now, real quick, let's just suppose, for example, what if you made a mistake and you thought that the y-intercept was, say, down here. Suppose I got negative 2 instead of 2. When I try to graph this, I graph it, it bounces, but there's no way to get down here without crossing the axis. And I can't do that because the only zeros were at 1 and negative 1. So if the graph can't do what you need it to do, check your arithmetic. You probably made a mistake with the y-intercept. The other thing, don't try to force it. You know, don't try to say like, oh, I need it to go here and maybe I can circle back around or something like that. That doesn't work, okay? It has to go through all of those points, you know, in the order that you see them, okay? So if the graph is not working, check your arithmetic mistakes on your y-intercept. Sketch a graph of f of x, a fourth degree polynomial with a positive leading coefficient, a double zero at x equals 0 and zeros at 5 and negative 5. So if x equals 0 is a solution, then x minus 0 is a factor. If x equal 5 is a solution, x minus 5 is a factor. X equal negative 5, x plus 5 is a factor. So this polynomial is f of x equal x minus 0. They said that was a double root. That means it occurs 2 times. Okay? Then I have x minus 5, x plus 5. So this is simply f of x equal x squared, x minus 5, x plus 5. That is fourth degree, which is what I wanted. It has a positive leading coefficient. Okay? If the zeros are at x equals 0, that's a double root. I will not cross the axis. And the others are at 5 and negative 5. I will cross the axis at both of those. Okay. My y-intercept. So the y-intercept is what you get when x is 0. When x is 0, in this case, I could plug it in. You get 0 times negative 5 times 5 or 0. But keep in mind, I already knew that because if the x-intercept is 0, the y-intercept is 0. Because the x-intercept is what you get when y is 0. If y is 0, x is 0, they're one and the same. Okay. So now this is a fourth degree with a positive coefficient. It needs to go up here and up here. So when I go to graph this, I know that it's going to cross, not cross, and cross. That's the only thing this polynomial can do. Fourth degree, positive coefficient. The next one, the degree. This looks like a fourth degree polynomial, and that is an even degree. The leading coefficient is 1/5 times 2 squared times 1 times negative 1. That turns out to be negative 4/5. Important thing is that is a negative leading coefficient. So I know immediately, fourth degree, negative coefficient. It has to go down in both directions. That means the answer to both of these limits, it goes down to negative infinity in both directions. What are my zeros, my roots, my solutions, my intercepts? Set each of the factors equal to 0, and you will get your roots to be what? 5/2, 0, negative 1, 0, and 1, 0. Any multiplicity? Yes, there is a multiplicity of 2 at the root 5/2. What is the y-intercept? The y-intercept is what you get when x is 0. So that is 1/5 times negative 5 squared times 1 times 1. That is 5. So 0/5 is the y-intercept. So 1, 2, 3, 4, 5. So that's 0/5. That is my y-intercept. On the x-axis, negative 1, positive 1, and 5/2. So I know that there's a multiplicity of 2 at 5/2. Do not cross the axis here. But I will cross the axis at 1 and negative 1 and the y-intercept. So the only thing the graph can do if it starts at the bottom left is this graph has to go up, hit the y-intercept, cross, and bounce, and then come back down in this direction. Okay, so it goes down in both directions, fourth degree, negative leading coefficient, and you see the behavior there at the x-axis. So sketch a graph of a third degree polynomial with a negative leading coefficient, zeros at -4 and 4, but only crossing the axis at x equal 4. So f of x equal x plus 4, that has to be a factor because of -4, and x minus 4, okay? These are the two factors, okay? So this corresponds to the root at x equal -4. This corresponds to the root x equal 4. It only crosses the axis at x equal 4. That means it does not cross the axis at -4. So what that means is this has to be squared, okay? So this polynomial will cross at 4 and not cross at -4. Now, read it real close. Third degree polynomial with a negative leading coefficient. The way to make this a negative leading coefficient is to put a negative sign right in front of all of that. So that is a third degree polynomial, negative leading coefficient, crosses at 4 but not -4. So 1, 2, 3, 4, 1, 2, 3, 4. So this polynomial will cross at 4. It will not cross at -4. And what is the y-intercept? The y-intercept is negative. You plug in a 0, you get what? 4 squared times -4. This is 64. So at 0, 64, that is the y-intercept, okay? So third degree polynomial, negative leading coefficient. That polynomial goes up to the left and down to the right. So I should be able to graph it. It goes from here to here through the y-intercept, and there we go. That's my third degree polynomial, negative leading coefficient, roots at 4 and -4, but it only crosses the axis at 4, which means it doesn't cross at -4. Now, putting a lot of things together, this is sort of the grand finale of today's lesson, putting things together we've done before. Start with this polynomial and let's graph it. Everything we've graphed so far has required us to be in factored form, okay? So how can we get it in factored form? Well, we can look at the rational roots, we can use synthetic division, we can factor it, and then we can write it in fully factored form, and then we can get the x-intercepts, y-intercepts, and the multiplicity. So the possible roots, okay, for this polynomial, that's plus or minus the factors of 24 divided by the factors of 1. That list is plus or minus 1, 2, 3, 4, 6, 8, 12, 24. Those are all the possible rational roots, okay? Let's start with 1. Well, if 1 works, the number should add to 0. Look at the coefficients. 1 plus 1 is 2. 2 minus 10 is -8. -8 minus 4 is -12. That does not add to 0. So 1 is not a solution. Let's try -1. So I'm just going to do synthetic division with 1, 1, minus 10, minus 4, 24. If I bring the 1 down, that's -1, 0. Multiply, that's -10. 10 minus 4 is 6. That is not 0. So 1 and -1 do not work. Let's move on to 2. One times 2, 2 times 3, 2 times -4, 2 times wait, let's see if I made a mistake here. Yes, my mistake was this coefficient is positive. So 2 times -12 is -24. That is 0. So x equal 2 or x minus 2 is the factor, okay? So I now have one root, okay? So 2 works. Let's see if it works again. So let's try 2 again. And let's see, 1, 3, -4, -12. 1 times 2, that's 5. 2 times 5, 2 times 6. That tells me it worked again. X equal 2 is a solution. X minus 2 is a factor. So at this point, I know this polynomial is f of x equal x minus 2, x minus 2, and the way that I read this right here is x squared plus 5x plus 6. So I need to factor x squared plus 5x plus 6. If that will factor, I'm looking for two numbers that multiply to 6 and add to 5. Those numbers are 2 and 3. So this is x plus 2, x plus 3. So this polynomial is x minus 2, x minus 2, x plus 2, x plus 3. Another way of writing that would just be f of x equal x minus 2 squared, x plus 2, x plus 3. So if we go to the next page, instead of f of x, it was actually p of x. So p of x in factored form is x minus 2 squared, x plus 2, x plus 3. Now we've got it in standard form, the original problem, and in factored form. What is the degree of this polynomial? Now here's a case when I've got it in two forms, certain things are easier to see on the left versus the right. The degree is 4. That is easily seen by looking right here. The highest degree term I have is x to the 4th, okay? Now you could look at the right and you could still figure out it's x to the 4th. This is an even degree. Leading coefficient, best place to see that leading coefficient on the left. What is the number in front of x to the 4th? That is 1. That is positive. Where do I go to find the zeros? Well, that was the whole point of factoring. You look to the right. The zeros are at 2, 0, negative 2, 0, and negative 3, 0. You can only get that information from factored form. Multiplicity, again, look to the right. I do have a multiplicity of 2 at x equal 2. You saw that x minus 2 squared, so that tells me there's a multiplicity of 2 at x equal 2. The y-intercept, you get the y-intercept by plugging in x equals 0. Easiest place to do that right now is on the left. If you plug in x equals 0 right here, you get 0 plus 0 minus 0 minus 0 plus 24. So the y-intercept is 0, 24. Now you could also get that on the right by plugging in x equals 0, and you would get 4 times 2 times 3. You would also get 24. In behavior, so this is a 4th degree positive coefficient. This graph goes up on both ends. So this graph in both directions heads toward infinity. That's enough information to graph this guy. So at 0, 24, that is the y-intercept. And then along the x-axis, I have things happening at 2, negative 2, and negative 3. Okay. The multiplicity at 2 tells me I do not cross at this point. But I will cross here and here. So the only thing this graph can do, it starts up, it has to cross, y-intercept, do not cross, and then go back up. So that is it. Okay, this was a long problem. Put a lot of things together, starting out with what we did earlier in the unit. So I started out with the original equation you see right here, getting it in factored form, using that information to graph it. So I pulled a lot of information together. You might not see something on a test this long. You might see it broken in different parts, mainly because it's easier for me to grade if a problem this is broken up into different pieces. Meaning, I might start the problem here, give you original and factored, and let you answer the question. You know, on your test, this might be a whole separate problem doing synthetic division. But this just pulls together why we did all of this, because being able to factor a polynomial is a step in then being able to graph a polynomial. Okay?